Hello students, welcome for this lecture on deep neural networks. So in today's class, what we're going to see is what is deep neural networks or what is deep learning. I hope you'll enjoy this session, and this is a advanced version of artificial neural networks, and what we're going to see today is deep neural networks, right? So deep neural networks is a topic which is the next step or the next level for artificial neural networks, right? So we went ahead. The people saw that artificial neural networks has some disadvantages or some limitations which they wanted to overcome, right? So what did they do? They tried to increase the number of layers. They tried to tweak the neurons, tweak their functions, tweak the activation functions, and so on, right? And they try to create something better, and that's where they arrived at deep neural networks. Now deep neural networks is a very new topic, and it's basically started off in 2010s, right? 2010 it started off basically accelerating the whole thing, because that's when we also had high performance systems, right? Computers became more faster, more better, and that is when we could realize all these structures and we could get better results, right? So in this lecture, in this class, what I'm going to focus right now on is how DNN is different from ANN. What are its applications? What are its uses? Why do we require DNN? Okay, why have arrived at a particular position where we have to use deep learning? Okay, that's what we are going to see in this particular class. Now, so this slide talks about the difference between artificial neural networks and deep learning, right? Or deep neural networks. Now we can see in this figure over here on the left hand side, we have a feed forward neural network. In the feed forward neural network, that means there is no feedback, there is no backward information being sent from one neuron to here. There is no backwards. That's why it's called as a feed forward, because it is looking in front, right? It is all looking in front. Okay. So that is a feed forward, a type of artificial neural network that I have drawn over here, and you can see there are limited number of hidden layers. The layers between input layer and the output layer is called as hidden layers, because these are not directly accessible to the user. User are accessible to input layers, which you can give the input, and it has access to your output layers from where he will be taking the output. Right, so that is the artificial neural network. In deep neural network, what happens is we have huge number of hidden layers. Okay, now here it's just a representation. Okay, just having 3 hidden layers does not mean it's a deep neural network. Okay, there are there are artificial neural networks that have 3 hidden layers or 4 or 5. When you talk about deep neural network, the hidden layers are really high. There's a large number of networks. There's a lot of interconnection. We have also seen there are a huge number of neurons over here at each layer, right? So it's a complex structure. It's a huge structure which has a lot of neurons, a lot of layers, and a lot of parameters are involved over here in deep neural network. So obviously you must be thinking, why we are going to such a complex structure? It will take a lot of time. It will be consuming a lot of energy, right, memory, etc. Why are we going to this? We'll answer all these questions in the upcoming slides. Now, what is the difference between AN and DNN? I've just tried to put a few details over here in this particular slide based on some parameters. Now, let's look at the definition of both of them. So, a neural network is a model of neurons inspired of human brain. We know this. We have done this in the previous unit, right? Of artificial neural network. So it consists of many neurons and their connections, and the neuron can represent an activation function, right, with several inputs and one output. That is what a neuron is. The artificial neuron is a basic building block of your artificial neural network, right? Fine. Then what do we have? Then we look at the deep neural network. In deep neural network, they are different from ANN in such a way that the basis of the depth at which they go is higher than your ANN. So number of hidden layers through which the data is passed, right? The information passing is large. We can say a large, right? And DNN have more nodes in all the hidden layers. This is what I've explained in the previous slide as well, right? The structure is more complex, is more deep, right? Now look at the components. Now components over here, we have neurons, the connections, weights, activation functions, and learning rate, right? Here you can see this DNN also has the same thing, but requires a large amount of hardware units like GPU and TPU. GPU is the graphical processing unit. TPUs are data processing units, huge amount of RAM, large power supply units, all these are required, right? Now the time taken to train the ANN is very less. Okay, the time taken to train is very less, right? But for DNN, it requires huge amount of time to train the network. Still, you must be thinking, why should we go for DNN? We'll come to that. Now, this is one thing. Now, this becomes less accurate. The ANN is less accurate, and DNN gives a very, very high accuracy, and the performance is so better than ANN. Okay. For so many years, from 90s to 2000s, we were happy. We were sufficient with whatever ANN told us, whatever ANN gave us, the results, the performance. But once we came to DNN, we realized that, okay, we can push ourselves, we can get better results, we can get good performance out of the systems, right? So that's why we have it. So that's the same thing in the performance-wise. It shows a little bit low performance, and your DNN shows better performance, right? Let's go to the next slide. Now, what are the difference between both of ANN and DNN based on the architectures, based on how it is. So you have single layer feed forward network, right? In ANN, you have single layer feed forward network, just as shown in the figure, right? It's a common type of neural network with input layer, hidden layer, output layer, etc. And they also have recurrent neural network where you basically process the data which is there in sequence. Okay, the data which comes in sequence, like at time t we have this information, at t plus 1 we have something else, and so on. The t minus 1, or you are basically working at the time sequence. You are working at information which is coming at different time levels, right? So it possesses a memory. So that's why when you have like this, you will have a memories to store the information, previous information. That's your past information, and take the new information and maybe work with past and new information together to give a better result or whatever process that you're doing. So recurrent neural network. That is your recurrent neural network. Now, there's also got a symmetrically connected neural networks where they are similar to RNN, that is recurrent neural network, with connections between units symmetrical. There are symmetrical units between them. That's the only difference. You don't have to worry much about it because we don't have the details of this in your syllabus. Now let's come to DNN. In DNN, you have unsupervised pre-trained networks. They are like pre-trained autoencoders. You're going to see what autoencoders are, right? We do pre-training of these networks. We'll come to that in the upcoming slides, upcoming lectures, right? And convolutional neural networks is one of the type of deep neural network we have. It uses a network. It's a network which uses images, videos, and learns on its own. It learns information from the data that is given to it on its own. It extracts features on its own and gives the results. That's the beauty of your DNN or the convolutional neural network. Now again, we also have a recurrent neural network over here. That is, when it's a very large, it's not similar to this. It's a huge structures where there are large amount of data. There are huge data sequences at different. You have huge amount of data at different timelines, right? You have a different timeline at past, present, and future. You have a lot of information that you are taking in. So basically, you can use this for live feed also, right? When your video recording or your continuous data or information is taken in, right? And you want to work on it and give results. So there is where we can have. So it's also a sequence kind of information required, right? And it can also work parallelly. If you can divide the information into some sections and do it, it can also possible, right? Now let's look at some more definitions about ANN and DNN. ANN basically is a structure consisting of ML algorithms where artificial neurons make the core of it, and we are trying to uncover a few of the underlying patterns from the data. From the data, we're trying to uncover all the information. We're taking information from it, and like how a human brain does, right? How a human brain differentiates between different objects, different things, few things, right? That's what we do over here, right? Now, in deep neural network, what we have is it's a branch of machine learning. Okay, or you can say a subset of AI, wherein we leverage a series of non-linear processing units, right? Now, what is non-linear processing units? We'll also come to that in the upcoming slides. It might be too much for me for you to understand this right now. Okay, so it is a non-linear processing unit comprising of multiple layers of feature transformation and extraction. Okay, we will come to this when we are looking at the structure, right, of the deep neural network. So it has several layers of artificial neural networks that carry out the whole process, right, of feature extraction and classification. Now, the first layer of neural network processes the raw data input and passes the information to second layer, and then second layer goes to the third. The information is extracted, tuned. We remove the redundant data. We only keep what is important to us, which helps us to decide or take a decision. That is, categorize or classify the information or data that we have. So your neural networks, the ANN, use neurons to transmit the data from input values to output values through different connections. Deep learning is also associated with the same thing, but you have a transformation or extraction of features that we do over here. It attempts to establish a relationship between the stimuli and the neural responses present in the brain. So this is basically what we are doing, is we are learning from our past. We are trying to extract the information. We are trying to understand what the information is, trying to keep it, place it somewhere, or basically your classification or categorization that we do, right? So this is a difference between your ANN and DNN. Okay. Now let's look at this the difference between machine learning and deep learning actually. So in machine learning, as I've told you in my previous introduction classes, that what we do is we have to do feature extraction. We have input, we have data, the information is given to us, but we need to extract the important features out of it, then try to create some network which will classify the information and give the result to us. Okay. Now here we're trying to decide whether it's a car or not a car, right? So we basically have information data of different types of cars, different sets of cars, how does a car look like, and so on. Then we extract all its features, and then we say that okay, this is a car and not a truck or a plane, or etc. In deep learning, what we do is we don't have to. This whole thing of feature extraction and classification is boiling down to one network which does everything for you. You don't have to bother about it. Here we have to sit and we have to code so that we do feature extraction, and then we have to model the classifier or the ANN network, and it will give. So we have to do two things over here basically. But here we have to just design this whole thing which does two things for us together at the one time. That's it. You just give the data to it. It will learn from its the data. It will extract features from the data. It will classify for you and give you the result. That is the beauty of your DNN or deep learning. So deep learning networks perform automatic feature extraction without human intervention, unlike most of the traditional machine learning algorithms. And feature extraction task can, a lot of people can require, because the data is huge. So a lot of people will be working to, extract good amount of features, right? And deep learning is a way to, remove that kind of a drawback of your machine learning, right? So also what happens is in deep learning you have supervised and unsupervised learning, right? So in deep learning you can do unsupervised learning wherein you don't have to bother, you just have to give the data, it will do it. So it trains on the unlabeled data, and each node layer of deep network learns the features automatically by repeatedly trying to reconstruct the input, right? That it draws input from its samples, and it attempts to minimize the difference between the network guesses and probability. So basically it's trying to reduce the error, or whatever model that it's trying to create and whatever data is coming in, it's trying to tune and fine tune it, try to remove the error out of that, right? So that's the beauty of this, right? That's the beauty of deep learning, right? So that's the major difference, right, that we have, and why we should go for deep neural networks compared to your artificial neural networks or other machine learning algorithms. Fine. Now let's come to different types of deep neural networks. So we do not have all these different types of deep neural networks in your syllabus, but we are going to look at convolutional neural networks for you in the upcoming classes. Now there are two major types of neural networks that we have. Sorry, deep neural networks that we have. That is recurrent neural networks and convolutional neural networks. In recurrent neural networks, there's a deep recurrent network which are capable to solving problems to audio data, text data, and time series data. So basically, when you have RNN, you should remember that it is a series data. It's a continuous data or sequence. It can be audio, it can be text, it can be video. It can basically you're working on the time series data. So RNN, that is recurrent neural network, captures sequential information available from the input data, and what it does is it can be used for natural language processing, time series data, machine translation, speech recognition, image caption generation. So all these are applications of RNN that we have already been done or using. Now, in the second case, in CNN, what we do is it generates a model. It creates models of DNN, which can be used for video processing and image processing. There are filters and kernels inside that, which are actually the building blocks of your CNN. We will see CNN in detail, right? That is convolutional neural network. By using conventional operations like kernels extract. Okay, it extracts correct and this is the one which extracts features. Automatically extracts correct features from the input data. This is the beauty that it has. Okay, what CNN can be used for? It can be used for image classification, object detection, image segmentation, facial recognition, image caption generation as well. So this is what are the typical the two major types of DNN that we have. Two major types. That's not the only one. There are two major ones, and what it does, how it does. That's what I try to show in this particular slide. Now let's go to the next one. Now the other most popular DNN algorithms that we have is auto encoders. Auto encoders we have in your syllabus. We are going to see this. Then there are other few things. There are multi-layer perceptron, RBFN, that is radial basis function networks, deep belief networks, generative adversarial networks. So a lot of work has been done in deep learning. There are a lot of different kinds of networks, and they are used for different kind of applications. Okay, and they are all of them are really good. All of them are, the performance is very, very high and better than your simple artificial neural network. Right? Now, what are the applications? What are the applications of your applications of your deep neural network? Now you may think that, okay, how you have seen at different places, and you have seen all these applications for all these applications have been also mentioned for other systems like ANN, fuzzy systems, genetic, right? We have mentioned. But what does deep neural do that is different from all of these? Now, deep neural network is slowly replacing all of these techniques for that. Maybe it is fuzzy or ANN, it is replacing it because it is giving a better performance, it is giving a higher performance. And now, as at the advent of, we have a large systems at your faster systems with huge amount of memory, and so you don't have to bother about. Earlier we have to bother, okay, the complexity, the time taken, and the memory that it consumes, right? Those were our concerns before, but now we don't have to worry because we have faster systems and we have a huge amount of memory at our disposal, right? So that's why this is slowly replacing the people. Like we have a lot of daily life digital products that we use, right? Popular assistants like Siri, Alexa, and Google Assistant that gives us suggestions. It gives us, it takes in our voice, it takes in our text information. It tries to predict what we exactly want, what we are looking for. Then the suggestion that Facebook, when the photo is uploaded, it tells you, right? Okay, is this you, or is this your friend? Do you want to tag your friend in this picture? How does Facebook or these people know? Because they are using somewhere down the line, they are using CNN, they are using convolutional neural networks where they have taken all your images, it knows how do you look like, it knows how a person is like. You have uploaded so many of your photos on Facebook and Instagram, it knows how you look like. So whenever your photo crops up, it will give you ask you, okay, this is Shreyas, or this is so and so person, right? Now, autonomous driving, also deep learning has been used in Tesla, right? Where they basically take in all the information, take in all the parameters from the surrounding, and autonomous cars have been designed. Because there are a lot of parameters that are coming in, and you need to take into environment, into your picture, and then take a decision where you take a right turn, left turn, straight, what speed that you're going to travel, who is crossing the road, etc., and so on. Now, the cat filter in Snapchat, these are basically product recommendations, etc. Now a lot of places DNN has been replacing the conventional neural networks or fuzzy systems has been replaced by DNN, right? So that's all for this lecture, right? And we will start with not auto integrator but convolutional neural networks in the next lecture. So that's it for today. Thank you so much and have a good day.